left, we have the stated problem. ABCG is a trapezoid, which means we've got two parallel bases, and they give us the height of the trapezoid. GCDE is a rhombus, which means all four sides are equal. And there's more to it about the diagonals we'll see in a second. And this half a kite really is just a triangle. And you know the base and the height. And here's the stuff you need to know in order to solve this problem fairly simply. The area of a rhombus, when you know the diagonals, is 1/2 the product of the diagonals. Of course, a trapezoid is the height times the average of the two bases. And you have to know that the diagonals of a rhombus are perpendicular bisectors of each other. So that's what's true. So if we go to the next board and fill in some of the given information, here's the key. In order to find the area of the rhombus, you need to know GC because that's one of the bases. And in the rhombus, the diagonals are perpendicular bisectors of each other. So if this little segment right here is 7 centimeters, so is this. And we can use the Pythagorean theorem. 4 squared plus 7 squared equals GC squared. So GC is the square root of 65. And now we can find the area of the trapezoid by saying it's the height times the average of the two bases. If we're going to get an exact answer, we got to leave the square root of 65 in the answer. 2 goes into 6 3 times, distribute the 3. There's a value for the area of the trapezoid. The rhombus, 1/2 the product of the diagonals. Notice that I got a 7 7 4 4, so the diagonals are actually 14 and 8. 1/2 of 14 is 7. 7 times 8, 56. And the half kite is just a triangle. So the base is 25 and the height or the altitude is 8. So 1/2 BH, 1/2 25 times 8. Add all those areas together. Of course, if you want an exact answer, you've got to leave the 3 radical 65, but you can add the 100, the 56, the 42 to get your exact answer. There you go. Hope that helped. If you have any questions, post a comment.